Hey guys, welcome back once again. In today's session, we're going to discuss about sample questions on electron configuration. So the first question here is, which of the electron configuration obeys Hume's rule? So you need to have an understanding of Hume's rule. What does the Hume's rule says? According to the Hume's rule, every orbital in a subshell is singly occupied with one electron before any one orbital is doubly occupied, and also electron in singly occupied orbital have the same spin. This is what the Hume's rule says. Now, while writing the electron configuration, first you have to fill the lower energy cell and then it goes into the higher order. And also, while filling the energy cells, first electrons should be filled up in a single way. Once they got put up in the single in every orbital of S, P, D and F, then only it is possible for pairing. So according to the Hume's rule, which option is the correct one? We go with the first choice. The reason here is, see, if you look at electron configuration, 1s2, that is first cell S suborbital is completely filled, 2s2 got completely filled. Then we are making with the 2p. Actually, p subshell suborbital can hold 6 electron, and we divide that 2 in x, 2 in y, and 2 in z. Okay, so it's a three-dimensional way we represent. So first we fill it like 1, 1, 1 in each x, y, and z. Once the 1, 1 has been filled, then we start pairing from x. It means x will be double, then y doubles, then the z if it is more electrons are available. So this is the only condition and only arrangement satisfies with the Hume's rule. So other three are not true, because you can see that in this one I cannot make a y as a double unless and until z has been have at least one. So here it is 0, so it cannot be make paired unless and until it is singly occupied. Here also same, you cannot put the z as a double unless and until y has been paired. So which is wrong? Here you cannot make a double with the y and z unless and until x has been paired with the double electrons. These all are the wrong arrangement. This one is the right one. Question number 2 says, which of the following element represents electron configuration below given by the Hume's rule? So this is the way of representing the Hume's rule. Which element is this electron configuration representing? So you just need to count the how many arrows it has. Number of arrows indicates the number of electrons that element has, and which is same as number of protons, that is the atomic number. We can use the periodic table, and from that when we can predict. See, 1s, the first subshell has 2 electron, second subshell s orbital has 2, and in the second subshell, that suborbital which is p has how many? 1, 2, 3, 4. Total how many number of electrons we are representing here? 2, 2, and total 4 are here. Add up them all. What is the number of electrons we are getting here? 8. So I have to look up to the element which has 8 number of electrons. That is same as atomic number of that element is 8. So you can refer to the periodic table and you can get that answer. So you can see that from the periodic table, the element whose atomic number is 8 is the oxygen. So we should go oxygen is the right answer to this question. So we should go with the last option, which is oxygen. Question number 3 says, which of the following represent a shorthand electron configuration of zinc, which is Zn? So they are asking us to recognize the shorthand electron configuration of element zinc. So look it out from the periodic table. What is atomic number of zinc? That is atomic number of zinc. Here you can find it is 30. So the zinc has total 30 electrons around it. So you should write the electron configuration of a zinc. First, let's write electron configuration of a zinc and then we'll come back. So if you write electron configuration of a zinc, how it gonna be? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and count it. How many has been done? So 2 plus 2, 4, 4 plus 6 is 10, 10 plus 2 is 12, 12 plus 6 is 18, 18 plus 2 is 20, then it's gonna be 3d10. So I am writing it. I'm writing the 4s2 before filling up 3d10, because while filling up the electron configuration, 4s2 suborbital will be filled first before filling the 3d10. So there is certain reason and all. So that is a long way. But understand, this is how you write. You can also change the order, doesn't matter. This can also be written as 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s2. You can write it in that way, no problem. So this is the actual electron configuration of a zinc. Now question doesn't give us the options in the way what I have written. They are asking you to recognize the shorthand. Remember, shorthand electron configuration always written with referring to the noble gases. Noble gas, that is helium, neon, argon, krypton, xenon, and so on. So recognize where is zinc, and zinc is over here. Now, which one is the previous noble gas for that? I can say here it is argon. Why I'm saying so? If you write an electron configuration of a argon, so you can see that electron configuration of argon has total 18 electrons. It will be written as 1s2, 2s2, 2p6, 3s2, 3p6. If you count them all, it's representing total 18 electrons. So you can see that 10 plus 8, which is 18. So this is the electron configuration of argon. So rather than writing the electron configuration of zinc in all detail, from here to here, we consider this is the electron configuration of argon. So the shorthand notation here is, we write it as AR with 4s2, then 3d10, or AR with 3d10, 4s2, doesn't matter. As I told, the order can be changed. So according to that, which one is the right choice, which one matches with what we got now? That is option B. So how do I predict whenever they ask you to shorthand notation for that electron configuration? Recognize that element belongs to which period. So the element belongs to the period 3, and look at the previous noble gas of that element. So previous noble gas is, sorry, zinc is belongs to the period 4, not 3. Okay, it's in a fourth period. This is the first one, second, third and fourth. So look at the noble gas in its previous row, previous period. So that is argon. Argon, with this all, we can recognize that that is the right electron configuration in terms of shorthand. So rather than writing that 1s2, 2s2, 2p6, 3s2 and 3p6, we are writing in a short way as this is the electron configuration of argon plus this additional things which corresponds to zinc. So make sense with option B. Question number 4 says, which of the following represents electron configuration of Mg2 plus? They are not asking us the electron configuration of magnesium. They are asking about electron configuration of magnesium ion. So what does this magnesium ion is representing? Whenever we are writing it as Mg plus, just a normal magnesium, how many number of electrons and how many number of proton that this representation has? Look at the periodic table. Magnesium atomic number is 12. Does Mg has atomic number as 12, so it has 12 protons. Okay, so as the number of protons, there should be number of electrons. So 12 electrons also we can say. But when I'm writing it as Mg2 plus, 2 plus indicating that this is the magnesium ion and it has 2 less electron as compared to proton. If I'm writing it as 3 plus, means it has 3 less electron as compared to proton. That many number of electron got gone out of that element and get converting into ion. So Mg2 plus has 10 electrons out, actually it's supposed to be 12, but as this 2 plus indicating that Mg magnesium lost 2 electron to get converted into magnesium ion, and they are asking you to write down the electron configuration for this. So while writing the electron configuration, I just need to write it as, say, follow that in the same way, 1s2, 2s2 and 2p6. Total add up how much we are getting, how many we are getting? 2 plus 2 is 4, 4 plus 6 is 10. So number what I'm writing here represent the number of electrons. Okay, So 10 electrons matches with the 10 electron of magnesium ion we are talking about. So electron configuration of this magnesium ion is 1s2, 2s2, 2p6. Keep it in mind. If they are putting it as a minus, you have to add that many number of electrons. If we are writing it as a plus, for example, when I'm writing it as Cl minus, chlorine minus, what is atomic number of chlorine? 17. So chlorine atomic number is 17. So chlorine Cl minus has total 17 plus 1, total 18 electrons. Okay, because this negative is basically negative 1 negative. So it has one extra electron than the a chlorine atom. So that is how you can recognize. If it is plus, reduce the number of electrons from that. If it is minus, add the number of electrons to the atomic number. So the right answer to this question is first choice, that is option A. Let's do the last question here. Question says, what is the number of valence electron present in the given electron configuration? Sometimes they do ask you to recognize the number of valence electron. So what is the number of valence electron, by the way? Valence electrons are the electron present in the outermost shell. While writing the electron configuration, electron present in the outermost shell are called valence electron. Those outermost shell might have s orbital, p orbital, d, f regardless. In the outermost shell, how many number of valence electrons are there? Those I have to select. If you look at on the electron configuration, this is the first energy shell, that is 1s. This together is representing the second energy cell. This is the first one and this is the second one, because 2s2, 2p6. This 2 is representing the second energy shell. This is representing a third energy cell, in which the number of valence electrons are how many? Whether it is in the s, p, d, regardless. Whatever the number of electron present in the outermost cell, whether it might be in the s orbital, p or d, that's what I'm trying to say, that all represents the valence electron. These all are representing the valence electron now. So 2 plus 4, total 6 valence electrons. So that is the right answer to this question is option D. So this is the right like number of valence electron that given element has. Can you tell me which is this element we are talking about? Add up, add there. 2 plus 2, 4, 4 plus 6, 10, 10 plus 2 is 12, 12 plus 4 is 16. We are talking about the element whose atomic number is 16, and that is sulfur. Sulfur is the one whose atomic number is 16, and you can see that sulfur has a valency of 6. Like oxygen, sulfur, selenium, titanium, they all has a valency of 6. So this is how you can recognize. Okay, so that's about the option D. That's it for today. I'll be uploading the new video with the new topics very soon. Please do like, share, subscribe to my channel so that whenever I upload a new video, you will be notified. Thank you so much.